Hello, 8th grade Grizzlies. This is Miss Brown, also known as the voice of your Edpuzzle. And today we are going to review for your atmospheric systems test, which is on Wednesday, November the 20th. So I'm going to walk through this entire review sheet with you. So go ahead and get your review sheets out, and we're going to go ahead and get started. All right, so we started this unit talking about water in terms of cohesion, adhesion, and surface tension. I'm going to talk about that a little bit later in the video because it's a little bit later on in the review sheet, okay? So let's go ahead and dive in. We started atmospheric systems, or weather, talking about the three types of heat transfer, which is conduction, convection, and radiation. Okay, so conduction is energy, or I should say heat. Let's go with heat because it is heat transfer. So it's heat transfer through direct contact. Okay. And an example of this would be a pot on a stove. Okay, please don't laugh at my drawings. So if we have the stove here, and this is the pot, okay, right here where the pot touches the stove, that is direct contact. Okay. And another way that you can remember conduction is direct contact. Okay, so it has to be touching. Right? The next one, and this occurs in a solid. Okay, the next one we talked about, and I want you to star this because this is the main one that relates to weather, is convection. And it's the transfer of thermal energy in a fluid. And I'm going to put liquid in parentheses. And also gas. Okay, and this is where your hot air rises and your cold air sinks. Okay, so I'm sure you've seen this symbol throughout the unit that we've been studying. So the warm air, it rises because it's less dense, and the cold air sinks because it is more dense. Okay, so this is heat transfer in a gas or fluid. Okay, and then the last one is radiation, and this is heat transfer by electromagnetic waves. Okay. And a couple of examples here would be a campfire. So if you're standing next to the campfire and you feel the heat. Okay, and the other one would be the sun. Okay. So we have the sun here, and don't laugh at my drawings. This is supposed to be a car, okay? And those electromagnetic waves, the radiation from the sun, that's what makes the car feel hot, okay? That's how the energy is transferred, okay? And then I'm going to attempt to draw a campfire here. So this is supposed to be the wood, and these are the flames. Okay? So if I'm standing by the campfire, I'm not touching it, but I can feel the heat of the campfire. Okay? That is another example of radiation. Okay, but like I said, the main one you're going to need to know and understand for your test is convection. Okay? Okay, moving on. What part of Earth receives the most radiation from the sun? That is the equator. Okay, warm air from the equator, warm air rises from the equator and sinks at the poles. Okay, and it's due to the heating and cooling of the air, and you can also add density. Okay, warm air is less dense, so it rises. Cool air is more dense, so it sinks. Okay, so warm air from the equator rises and sinks at the poles due to heating and cooling of the air. What happens when molecules in fluids? Your fluids is your gases and liquids. Okay, when they're heated, they rise. Okay, so remember, so this is convection. Okay, that's where warm air rises, cold air sinks. Okay, so remember, a fluid is a gas or a liquid. That's convection. So when they are heated, they rise because they're less dense, and then when they start to cool, they sink. Okay, air pressure. Air pressure is defined as a force. It is defined as a force that is the result of the weight of a column of air pushing down. Areas of high-low air pressure always want to move to areas of high-low air pressure. Okay. Air pressure always wants to go from high to low. Always. Please write this down. This is straight off your test. Goes from areas of high to low. Alright, so moving on, we're going to go over land and sea breeze. Okay, so the first picture, this is the sea breeze. Okay, this occurs during the day, and your land breeze occurs at night. And I'm going to pause for just a second. I need to refocus. So. Okay, here we go. All right, so like I was saying, sea breeze occurs during the day, and this is a breeze or wind that blows from the sea to the land. Okay. All right. So this is your warm air rising, and then it cools and sinks. And then we're going to write, again, this occurs during the day. All right. Land breeze. Land breeze occurs at night, and this is a breeze or wind that blows from the land to the sea. Okay, so you can see it in this picture. Okay, so warm air rises, cool air sinks. It's going from high to low because the land is cooler at night, and the day and during the day at night the land is cooler and the sea is warmer. Okay, during the day the land is hotter and the sea is cooler. So it's going from high to low, high to low. All right, moving on. What kind of weather follows a high pressure system? Remember, high pressure is happy weather. You're going to have clear, sunny, and dry. What type of weather follows a low pressure system? Remember, low pressure system, you get lousy weather. Cloudy, rain, wind. Okay, and we did that on our brain dump. High pressure is happy weather, low pressure is lousy weather. Please, please, please remember, high and low pressure do not control the temperature. Okay? Temperature is influenced by fronts. Warm fronts, cold fronts, stationary fronts. Your high and low pressure will just tell you whether it's going to be clear and sunny or cloudy and rainy. Okay? All right, moving on. Okay, I'm going to pause for just a minute. All right, the next thing we're going to go over is the symbols for the fronts. All right, you do need to know this for your test, and that is the symbols for the cold front, warm front, stationary front, and occluded front. And you need to know what type of weather these different systems bring. So we're going to go over that next. Okay, so draw the symbol for the cold front. Cold front is always blue. And remember that these little mountains or icicles, however you want to think of them, those tell you the direction that the front is moving. And I also want you to remember, ladies and gentlemen, this is the beginning of the front. The cold air is back here. Okay? So if you think of this as an army, okay, this is the beginning of the army. The rest of the soldiers are back here. This is just where it starts. Okay? So just remember the cold air is here. Okay. All right. So what happens after a cold front passes? You get cooler temperatures. So I'm going to write cooler temps. Okay. And remember that the cold front is blue. All right. Next one is a warm front. Warm fronts are red with these little half circles. I think of them as half suns. Okay. And after a warm front passes, you get warmer temperatures. And you also can have light showers because warm air is humid. Okay. All right, next one is the symbol for a stationary front. Okay, this is the one that I call the tug of war. So you have cold air that wants to go down, you have warm air that wants to rise, and they're literally in a tug of war. And neither one has the energy to move the other one, so it's a stationary front. It just sits. And they can sit for days and days and days. Okay? And I think my description is on the next page. Okay. I don't have a box. My box is missing, so we'll just write it underneath. So, What type of weather does a stationary front bring? It brings snow, rain, and fog. And these things can last for several days because it's stationary. It doesn't move, it just sits. Okay? All right, and then the last symbol is the occluded front, and that's where you have a warm air mass trapped between a cold air mass. So here's your warm air mass, and you can see it's trapped between two cold air masses. Okay? And an occluded front brings tornadoes, thunderstorm, I'm just going to say violent weather, and I hate to use the term violent, but when I say violent weather, I mean very aggressive weather. Like I said, tornadoes, thunderstorms, not hurricanes. Hurricanes is warm ocean water, which we'll talk about later. Okay, so where I come from in Michigan, we got occluded fronts a lot. And the sky would literally be like this weird greenish color, and we would have tornadoes, very heavy thunderstorms to where you literally couldn't see out the window. Okay, moving on. Okay, what type of weather happens after a stationary front passes? Okay, remember the stationary front is the one where it just sits for days and days and days. So what generally happens is clouds. That's already filled in for you, so I'll just go ahead and highlight that. And then what type of weather happens after an occluded front? Usually you get clear skies. So the weather will be really bad, and then the weather will turn really nice like nothing ever happened. Okay. And sometimes with the stationary, you can get rain. And if it's cold enough, freezing rain. And then after an occluded front, you get typically clear skies, and you can have warm or cool temperatures. Let's move on to the next part. So we are using this weather map right here to answer these questions. So how many fronts do you see on this weather map? Well, there's 3. Here's 1, 2, and 3. Okay. This one is stationary. This one is a warm front. And this one down here is a cold front. Okay, so there's 3. A stationary, a warm, and a cold. All right, find the warm front near New York. This is New York. What direction is it moving? Remember, these little half circles, and here the triangles, it tells you the direction that it's moving. So if we do never eat soggy waffles, this warm front is moving north and also slightly west. So we're going to say northwest. Okay. What type of weather is Texas experiencing? Well, there's a high pressure system here in Texas. So it's going to be sunny and clear, and also dry. Just remember, high pressure brings happy weather. So it's going to be clear, sunny, and dry. Okay? Mississippi is right here. Okay? And you can see a cold front has just passed by Mississippi. Okay? Remember I said this is the beginning of the front. The cold air is here. So since this cold front has passed through, the cold air is here. So Mississippi is having cooler temperatures. And they might also have some light rain, but we're just going to say cooler temperatures. Okay. All right, what direction is the stationary front moving? It's not. And they're referring to the stationary front right here. It's not moving. How do you know? Stationary fronts don't move. Okay. All right, next question. Okay, mine is, okay, I don't know. Yours may not have number 13, but we'll answer it anyway. What type of weather is Houston having? Well, Houston is here. It's in Texas. Sunny skies. And it's clear because of that high pressure system. Okay. What can North Carolina is right here. What can they expect over the next few days? Okay, well, this is North Carolina. There's a cold front coming there. So when the cold front passes, I'm just going to put equals cooler temperatures. Okay? So once that cold front passes, you're going to have cooler temperatures. And we'll also say possible storms. All right. All right, number 15. Ocean currents affect weather patterns by distributing heat from the uneven absorption of solar energy. Use the map below to explain what this means. Okay, we're talking about this map right here. So basically, if you live near a cold ocean current, you're going to have cooler weather. Okay, if you live near a warm ocean current, you're going to have warmer weather. So for example, Houston is near the Gulf of Mexico. The Gulf of Mexico is a warm current. That means we're going to have warmer temperatures pretty much year round. On the opposite end of that, California, the Pacific Ocean, is a cold current. So cities like San Francisco that are on the bay, cities like San Francisco that are off of the Pacific Ocean are going to have cooler temperatures because of the cooler ocean current of the Pacific Ocean. So just know if you live near something with a cold ocean current, you have cooler temperatures. Warm ocean currents bring warmer temperatures. Okay, and then the uneven heating, also this is convection because the warm air rises and then the cold air sinks. So it all kind of goes back to convection. Okay. Warm water is located near the equator. Cold water is near the poles. Here's your equator. The equator gets direct sunlight year-round, whereas the poles does not. Okay. All right. We talked a little bit about hurricanes. You need to know you need warm ocean water for a hurricane. And it's usually, the water usually has to be 85 degrees or higher. Okay, so warm ocean water is what drives a hurricane. It's not a warm front, it's not a cold front, it's not high or low pressure. Warm ocean water is what fuels and strengthens a hurricane. What slows a hurricane down? Cold water, and also add this, moving over land. Okay, that's why when hurricanes hit land, they usually turn into a tropical storm or a low pressure system, because they don't have that warm ocean water to fuel it anymore. And also, like I said, cold ocean water will slow down a hurricane. Okay, these are kind of highlighted already, but I'm going to highlight them again and talk about them. So we talked about cohesion and adhesion and surface tension. So if you look at the brain dump video and you do the brain dump before your test, okay, but I'm going to review. So cohesion is water attracted to water. Okay. Adhesion is water attracted to another surface. Okay. All right. So, what term describes the attraction of molecules of the same substance? So, water attracted to water is cohesion. What term describes the measure of how difficult it is to break the surface of a liquid? That's surface tension. And I did not define that over here. But basically, surface tension is those water molecules on the surface that are packed tightly together. They're very close to each other. So, that allows, like we talked about in the notes, the water strider to be able to walk across the water. So if you have something like soap, will break the surface of that liquid, and it'll break the surface of the water, and it will break the surface tension. That's what I'm trying to say. Okay, what term is used to describe the attraction between molecules of different substances? That's adhesion. Okay. And let me give you an example of cohesion. This would be a water drop forming. And I'm going to put in parentheses like a faucet. So when you turn on a faucet and that water comes out, those water drops come out, that's water sticking to water. That is cohesion. Adhesion would be water stuck to your, let's just say stuck to your hair, or water stuck to hair. That's adhesion. All right. Dewdrops that can be seen clinging to strands of a spider web. That is adhesion. And then a raindrop, oh, there's my example. A raindrop taking shape as it falls, that is cohesion, because it's taking a rounded shape as it falls. So that water is being attracted to water before it falls. Okay, let's move on. All right, these are questions straight off of your test. So let's go through these together. Okay, so in this question so all of this is part of this question right here. So let's ignore this for the moment. All right, so it says, which statements describe either a stationary front or an occluded front? Okay, and they give you pictures here. All right, so I will tell you this is straight off your test. So you're going to have 3 answers here, and you're going to have 2 answers here. Okay, so let's do this. This will probably be helpful if we draw out the symbol for a stationary front and a symbol for the occluded front. So here's your stationary front. And then here's your occluded front. So remember, the stationary front, warm air wants to rise, cold air wants to sink. They're in a tug of war. The air masses are not mixing. They're in a tug of war, and neither one has the strength to move the other. So bam, I just gave you an answer. This is A. Air masses do not meet. That's a stationary front. So we're going to put that one here. Occluded front is purple. That's where you have the warm air mass. This is warm air. It is trapped between 2 cold air masses. Okay? So that's letter E. So this is occluded front. So we're going to put E here. All right. Now that we have the symbols drawn out, we can answer the rest of these questions. So B, or put these statements where they go. So B, warm and cold air masses meet. They meet, but they don't mix. That's stationary. Okay. Causes heavy precipitation. Well, if you remember back back on the front where we talked about the occluded front, let me find mine. Okay, right here, we said that the occluded front can cause tornadoes, thunderstorms, okay, and violent weather. You can also have rain with a stationary, but this one is saying heavy precipitation. Heavy precipitation. That is going to be your occluded front. Okay. So violent weather, thunderstorms, tornadoes. Your stationary just gives you rain. Okay. So that's the difference here. Heavy precipitation comes with the occluded front. Days of rain, that's your stationary. Okay, so remember I told you you're going to have 3 answers here and 2 here. There you go. Alrighty, we're going to move on. We have 2 more questions and then we're done with the review sheet. Okay. How can the interaction of 2 air masses be described? So this is your word bank. Warm, cold, precipitation, and evaporation. So these are the 2 words you're going to use, but we've got to put them in the right spot. So a stationary front has formed right here. Here's your stationary front has formed. If the cold air mass begins to move forward, it's most likely going to become a cold or a warm front. Well, if the cold air mass moves forward, it's going to become a cold front. Okay? But if the warm air mass has more energy and it rises, you're going to get precipitation. Because remember, with a warm front, you get light showers and warmer temperatures. All right, last question. And like I said, these questions on this last page, ladies and gentlemen, is just straight off your test. So make sure you are writing this down. Okay, for this question, I need you to add the word less. Okay, so not all of the words in this one are going to be used. Okay, before we answer this question, I want to define the word absorb. just to make sure you understand it. Okay? So absorb means to soak up. All right? So like a sponge absorbs water, it just means to soak up. And this includes energy. Okay, so energy can be soaked up, let's say, into the clouds. All of the moisture can be soaked up in the form of energy, and then you get, like heavy rain and precipitation. Okay. All right, so let's go ahead and answer this question. Warm air holds blank water vapor than cold air, more or less. Okay, warm air is going to hold more water vapor than cold, because remember, it's less dense. When the sun warms the air in the land near the equator, warm, moist air rises because it is more or less dense. It's less dense. Okay? It rises until it cools. Okay? And I'm going to draw this convection current again. Warm air rises, and then colder air sinks. Okay? This process blanks energy. This process absorbs or soaks up energy. And then when the clouds and the water droplets become large enough and it gets too full, you have rain. Okay, ladies and gentlemen, that is the review for your atmospheric systems test. I did do a brain dump video. I would encourage you to watch that video, and I would encourage you to ask your teacher for a piece of paper before you start your test, or when you get your test, before you even open your test. It only takes a few minutes, ladies and gentlemen, to make a quick brain dump. And like I did in the brain dump, you probably want to brain dump the types of heat transfer, conduction, convection, radiation, cohesion, adhesion, surface temperature, the symbols for all the fronts, and high and low pressure. Dump that out, ladies and gentlemen. Get it on a piece of paper, and then you can refer to that during your test. Okay? Now you can't do it ahead of time, but you can take 5 to 7 minutes before you actually start your test to write all that information down. I would encourage you to do that because it will be helpful. So on behalf of Mr. Winter, Ms. Ludeman, and Ms. Ford, this is Ms. Brown, aka the voice of the 8th grade science ed puzzle. Study hard. This is a fairly challenging test. There is a lot of reading on the test, so make sure you get a good night's sleep and watch this video, and we know that you all are going to do very well.